Hello everyone, welcome to my thesis in 3 presentation. My thesis is about using data spaces for lifecycle data management in civil engineering industry, construction industry. 394, this is not just any random number, it is the volume of data volume predicted by Statista in the year 2028, for the year 2028. 394 zettabytes of data that we are having, that we'll be having in the future. So data is not an oil, it's the new water. Why I mean this is like, imagine that data is flowing, free flowing like any river, and which where we are not using it, it is untapped, it is unused, or it is wasting. So this will not add any value to any industry or any business in particular. Construction industry is also not different, but what we have done is creating or constructed a small parts of the dam, but still we are allowing lots of data to move from unused. And the state of construction industry is like 95% of data, the construction industry data is unused, or it is not in the usable format. When I say it is not in the usable format, some data is missing, some data is incorrect, or it can be irrelevant data. So how should we solve this problem of managing the construction industry data? There are majorly 4 reasons or 4 causes that can lead to efficient data management. First one is there are too many data silos. For each phase of the building life cycle, we use different tools. When we use different tools, we are actually creating more data silos, because that data in that particular tool is not carry forwarded to next phase of the building life cycle. And there is also a problem of heterogeneous data, because building is a complex system of systems. You have data from each system, and each system's data is also different in various formats. So next thing is data silos. This is from the idea of knowledge islands, where you have siloed data in each and every island, and you are unable to tap or make use of or add value using that data because they are disconnected. Of course, there are existing methodologies that are connecting the data. And data is not fair. So it is not fair is principles for findability, accessibility, interoperability, and reusability. So the existing current construction data is not fair. And each of these causes has an effect. So first effect is lower interoperability because of multiple softwares that we are using in each building life cycle phase. And poor scalability, because your systems are, there are a lot number of systems, the data is heterogeneous. It is very difficult to scale or add new additional system into the existing data models. And because of data silos, you create fragmented systems. And security. So these are the 4 points that my thesis is working on, where I want to use a decentralized data framework for managing building life cycle. This is a general exchange process where you exchange data between provider and consumer, and I'm using a data space component in between that will exchange data, which addresses all the above four problems that I mentioned about. And I'm collecting data from a project where I'm using different kinds of buildings and different life cycle phases. And all I would wanted to say is this is important because data is not the new oil, it's water. But water is very essential for making life sustainable, and in the context of buildings, it will make the building smart and sustainable. Thank you.
Thank you very much.